Okay, so today we're going to be transforming and combining random variables. That usually means adding, subtracting, multiplying, dividing, that kind of thing. Sometimes it gets complicated when you have random variables. Here's the homework from the other day. Okay, so remember we talked about Pete's Jeep tours the other day. There must be at least 2 passengers, etc. Here's the data. Describe its shape, center, spread. So they took it, you remember doing a histogram and taking the data from a table and drawing the histogram. That's relatively easy. Of course, to find the expected value, you would either do 300 times 0.15 plus 450 times 0.25 plus ... And keep going to find your x bar or your expected value there. That's the mean. You would do that, or you could alternatively. Okay, so you could put the data in your calculator. This is just refreshing on stuff you already know. Go to a calculator page, do linear regression. A plus bx we usually do. So total, and so we get our, I don't want to do linear regression, sorry. Sometimes you do the wrong thing. You get a different mode in stats. Menu 611 is one variable stats, do one list. First list is total. Second list is the probability list. And do one variable stats. And there's the information we need to know. We see now that, see if this moves over here. So that's the information we need to know. We now know the x bar. Oops. So we know the average money is 562.5. We know that standard deviation is 163.459. So we have those two, the measures of center and measures of spread. So measures of center, this is the mean. Other measure centers would be the median. Those are the main two. This is standard deviation. Other measure of spread that we do use occasionally is IQR, and sometimes the range. We prefer the first two there, but those are measures of center. These are measures of center, these two. And these are measures of variability, or sometimes we use the word spread. Okay, so let's talk about shape, center, and variability. So shape, what is the shape of this graph? Roughly symmetric. And we just talked about this, what's the mean? The center is 562.5, and the standard deviation is 163.459. And those are dollars. We probably should have added dollar signs to those. So those are measured in dollars for this problem. Okay, not bad, right? Nothing new there. It costs $100 to buy permits. This happens sometimes when you go to a place. Sometimes you have to pay a fee to do that. And there's also the price of gas because you're operating a vehicle, maybe a ferry they're taking. So it could take a little bit. So if it costs $100, V is the profit he makes. So the cost minus the $100 fee there. So how much he took in, or the average there. So this is the new table. So you notice that all the numbers, if you look back at the old one, the profits are all $100 less. But the probabilities are actually the same, right? That there's still the same number of people going to those trips. The profit just went down when we realized, oh, there's some extra costs here. There's $100 of cost I did not factor in to start with. And so we should have probably done that. This is probably the actual, takeaway from this trip than what we originally had. So how will that affect the measures of shape, center, and spread, or shape, center, variability? So, wow, the shape is the same. I don't think that's changed. The average should go down by 100, I believe. So if I type this data in, let me just, so let's see here. So the mean was 462. Sorry, the mean was 562. Now it's 462. The standard deviation was 163. It's still 163. So there was no change in this one. This one changed. There was no change in this one. So when you add or subtract, measures of center change, measures of spread or variability do not change. Let's look at just a picture of it. I don't know if this will help, but I graphed it. These are the two histograms. You can kind of tell the shape is the same, but it's just been moved over a little bit. So the new mean is going to be, smaller now. It was 562, now it's 462. But the spread or variability, it looks like the same amount of spread. It's just been moved over, right? So adding, subtracting, this is what it does. So that's what that is. But this, if you want to summarize what adding, subtracting does, I would write this down in your notes. That's what I would write down. Doesn't change the shape, by the way, right? So shape wasn't affected. And in this case, adding, subtracting didn't change measures of variability either. So if he works 10 hours a day, he wants the profit per hour, which means we're going to divide by 10, because it's a 10-hour day. Ooh, long time. So the table of histograms, so here's the table. So hourly profit, oh, that changed, right? So if you put in that data, that's the shape. Looks like the same shape, by the way. What do you think is going to happen to the mean? So it was 562. Now it's, or I guess the new one was 462.5. And so if you just divide that by 10, you get 46.25. Okay, so the center was affected by division. The variability was 163.46. Now it's 16.346. So I think we divided by 10. So both variability and spread are affected by multiplication or division. So that's true on both. That's basically the concepts for the lesson today, but we're looking at a couple more little examples, and it gets a little bit more difficult when you're combining two different random variables. So these are the means. So the tuition is, so this is Eldorado students, full-time, June 12 and 18. So the mean amount of hours taken is 14.65. That seems kind of low. I thought 16 was about average, but I understand. Standard deviation is 2.056. The tuition is $50 per unit. Let the tuition charge for a randomly selected student. So you would just, definitely the shape is roughly symmetric. But multiplying by 50 doesn't change the shape. It does affect the mean, right? So whatever the mean was, 14.65, it's going to be a much higher mean. It does affect standard deviation. Multiplication does, so you're going to multiply that standard deviation by 50 to get 102.80. In that case, they're saying B, even if it's a negative number, you're multiplying by a positive number for standard deviation. I don't think standard deviation can be negative, so that would be the issue there. No formulas for these are given on the AP test. Okay, so now here's Erin, I guess the sister, also has some GP Ventures. They, fortunately for us, calculated the means and standard deviations. We don't have to do that. So, but we do need to do this. They want to sum up. They're trying to figure out maybe how much on average they're making together. So you're going to add up the two means, and you do that exactly the way you think. You take the two means, 3.75 and 3.1, add them together to get a total of 6.85 passengers per day. The mean of the difference is the number of passengers that is also exactly what you think would be. You're just going to subtract those two numbers to get your 0.65 passengers per day on average. It sounds like Pete must have more passengers than Erin. Is that right? Or does Erin have more? x plus y. Okay. So the mean, you just add. So they're just kind of saying in words, you just add, subtract. The order is, of course, important in subtraction. Okay. Follows distribution with the mean. So these are two different college campuses. Calculate the mean. So what are we going to do with those two numbers? If we're going to, subtract m minus r, so the mean of m minus the mean of r, and that will give you the mean difference there, 92.5. The average difference would be about $92.50. I don't know why they're saying negative. Oh, I see. 732 minus 825 is negative. They just forgot to put it there. It's a mistake in the PowerPoint. If knowing the value of x does not help us predict the value of y, then x and y are independent variables. In other words, two variables are independent if knowing the value of one does not change. Remember, they have no effect on each other. Hopefully, this is an easy concept for you now. Okay, here are the probability distributions. What is standard deviation? So this one will shock you. I hope you're sitting down. This is not normal. What we have to do is, oh, wow. We change both the variances by squaring them, add them together because variances add just fine. And then we take the square root to take it back to some kind of idea of standard deviation. So that's the move. It's a formula. Standard deviations are weird. You got to be careful with those. So that's the formula right there at the bottom. That's the tricky one. I feel like adding, subtracting is somewhat intuitive. Well, no, I guess they're all about this. But the weird thing also is when you subtract, the variance goes up. So you're still going to add them using the formula. So the formula at the bottom really works for both cases, adding or subtracting. So it's really strange. Standard deviation does work kind of strange. But if you think about it, if you're subtracting two with different amounts of variability, it makes sense to me that the variability would go up. You could have a large difference between the two. So again, so the means, we just subtract like normal. Knowing the amount, explain why is reasonable to view M and R as independent. Okay, so let's think about the context here. On the main campus and the rural campus, you might have different kinds of folks. I just don't think one would affect the other. I have a feeling they're totally different kinds of folks, and so I don't think they will have an effect. That help us predict the amount spent distribution of randomly selected full-time students. So yeah, knowing which campus they're on didn't really help us predict it. So as we say, they're independent. Calculate the standard deviation. So take those two standard deviations and do what? Square each of them. That makes them variances. Add them, and then square root the total. And so you get 163 when you do that. They typically vary from the mean by about 163. Okay, x plus x is 2x. X plus x, is that 2x? Okay, let's just see. So that's the mean standard deviation. If you roll 2 dice, that's the outcomes. You can get snake eyes. It's a very low chance. So that would be 2, a sum of 2. You can also get lucky and get a sum of 12. So same mean of 3.5. So if you add the means, you get 7. That makes sense. Because the outcome of one die tells us nothing about the outcome of the other die. They're both independent. So if they're independent, we can use this formula. We say, okay, let's make them variances by squaring them, add them up, and square root them to get back to a standard deviation for the addition of those two. So if you multiplied everything by 2, what's that going to do? The means are going to change. Standard deviation is going to multiply as well, right? Because multiplying affects both mean, measure center, and measures variability. Okay, that's your lesson for today. If you want to keep going and look at these problems, I'll pause and then put the solutions up there for you. And this one, if you want to pause it and then find the answer, and this one, if you want to pause it and find the answer. That's your lesson for today.